Ensemble learning. Okay, so ensemble learning, we're going to essentially have our data, and I'm going to talk very generically right now because there's different types of ensemble learning. There's different methods. But so we've got a bunch of data, and we want to make use of multiple learners on that data to kind of make more efficient use of our learners. And the term is often used, don't put all your eggs in one basket, and that's kind of what we do when we do ensemble learning. We're not just relying on a single model. We're using multiple models, and that kind of creates a less overfit model because if it keeps from one single learner from creating a model that's overfit. And so there's different types of ensemble learning, and this will make sense as we go along. That kind of general statement I made before, what happens. But initially, this first video, I'm going to talk about what's known as bagging. And there's another name for it. This is kind of the slang term, I guess you'd call it. Uh, the full name is Bootstrap aggregation. Boot. And I tend to like that name better, and I'll tell you why here in a second. Bootstrap aggregation. Okay. So let me take a step back, and I'll tell you why I like that name more. So bootstrapping is a technique from statistics where we have a set of data, say 100 records of something, and we want to resample that data to do some sort of statistical analysis, right? It's kind of in the same spirit as cross-validation. The difference between cross-validation and bootstrap aggregation is that bootstrap aggregation is with replacement. So let's write kind of a feature list here. We'll say that it's, well, I don't want to, because they're kind of different thing. I'm just gonna say that one of the features is with replacement. I don't want to use the cross-validation comparison too much because they kind of do different things, but they're sort of similar. So we sample with replacement, and let me write the full thing. I can say sample with replacement. So that's what we do when in statistics when we're bootstrapping. We have an amount of data. So say we're looking at a poll of all possible voters in the country, and that's usually the example given because it's not possible to poll every person in the country. All you can kind of do at any given point is just you take a sample, and within that sample you resample. And so you've sampled 1,000 people and you want to kind of get more use out of your data, you do resampling. So we're going to do sampling of the sample with replacement. In our machine learning and data mining context, we actually take our data and we're going to sample. We're going to build some sort of model. So this is kind of the bootstrap part. Let me write this in a different color here. Let me say this is so write this next one in red. Within the data mining and machine learning context, when we're bootstrapping, we build a model from the sample. So say I've got 100 records and my sample size is 30. I'm going to take 30 from all my available sample data points, and I'm going to build a model. And then I'm going to do that again and again and again and again. And so I've got, say, 10 different models, and like I mentioned with cross-validation, we can just keep on sampling. We have a sample size, we have the number of iterations that we go through. So say our sample size is 30 of the 100, and say we go through 10 times and we sample, and what's important is with replacement. So obviously we're going to have to reuse data, right? We don't do that with cross-validation, but this is with replacement. The second half of Bootstrap aggregation is to actually combine those models somehow. So this is the second part. So our bootstrapping is we sample with replacement, then we build a model from that sample, and so now this last part is going to be to combine the models, and then this is the aggregation part. So you can see where the name comes from. It's supposed to be an R. Okay, so you can kind of see where the name comes from, and a little bit why I prefer the name Bootstrap aggregation to bagging, because it kind of really explains what's going on. And so we have different techniques of actually combining these things. So let me take a step back before I talk about these techniques. Hopefully this makes sense why you would keep any single model from overfitting the data. Because what might happen is you might have outliers, and this is kind of one of the reasons that this ensemble learning, this bootstrap aggregation, kind of works so well. It helps. So let me group all these together. This is kind of the process. This is what happens. We sample with replacement, we build the model from the sample, and then we combine the models. Now I'm going to kind of write what it helps with. So now we're saying that the reason it's good, the reason we want to do this, is it helps with outliers. Helps keep outliers in check. It also helps from building any single model that's vastly overfit. So it helps with overfitting. Okay, so I hope that makes sense why. It's because we're just taking a part of the data. So say we have a few outliers, sometimes we're gonna sample those outliers, sometimes not. If we've got a lot of noisy data, sometimes we're gonna sample that noisy data, sometimes we're not. And then in the end, when we combine our model, what happens is the outliers and that noisy data and that overfit data has less effect because we combine them all. And so how do we combine? So I'm gonna scroll down a little bit here. We're kind of on a slightly new topic. So how do we actually combine the data? I should say, how do we combine our models? And that answer depends on if we're talking about regression, numeric regression, or if we're talking about classification. So with regression, because it's kind of numeric, we sort of have the luxury of using some sort of central tendency measure. So we can either find the mean or the median. So we combine them using the mean or the median. With classification, what we do is we do something called majority voting. And you can kind of see why why would we do that, right? So say we come up with some 5 different regression models, and then we want to kind of combine them into a single value, right? So I have 5 different of these lines, and then I have a new value, an unseen value, our test value, and I want to know what the result is. So basically, I run it through these 5, and I take the average. And so I'm either going to take the mean or the median. I think that the median is typically used because you could have a single bad model that picks some really weird value, but if we use the median, it kind of keeps any one bad model in check. The mean kind of allows a single bad model to kind of bleed into our results a little bit more. With classification, say we built 5 classifiers, what we do is we take the majority vote. So we have a new instance that we want to classify, and if we pass it through our 5 classifiers that we've built using the sampling, and then we want a final value. Say we're using the Titanic data, we want to know if they survived or they didn't survive. And so what we do is we pass it through those 5, and then we say, okay, what was the majority vote? Say 4 of the 5 voted for survived, then our final output, our single output, is going to be that they survived. So it's not too tricky of a concept to kind of get. You don't have to really do any of this manually. Most tools have some sort of bagging built in, Bootstrap aggregation built in. And so let me just take a minute here, and we'll just review. Okay, so we're talking about ensemble learning, and then the topic we're talking about is Bootstrap aggregation, and this kind of comes from statistics. And so when we do sampling with replacement of some sample or some data that we have, we're kind of resampling. We replace it, and then we build the model from our samples. And so the first part is the bootstrapping. That's where the name comes from in statistics. And we build some models. And remember, because it's with replacement, we're going to have some duplicate data, but it turns out that doesn't matter. The statisticians prove that either way it still helps, and they prove that through bootstrapping. Bootstrapping is a very old technique, and you can probably find it in a lot of statistics books. And then we combine the models somehow. We do some aggregation, and then we kind of talked about how exactly we combine these models. If it's a numeric output, if we're doing regression, we take the median of the different models. If we're doing a classification like a J48 or something like that, in SVM, we have majority voting. So we get an output, we get a classification, and then we vote on those. And then the whole reason we want to do this in the first place is because we can keep outliers in check, and we can keep we can kind of help with overfitting. And no single model. Let me kind of squeeze this in. No single bad, say bad or crazy. Some model comes up with some crazy answers. No single bad or crazy model can, let's say, affect performance. Okay, so hopefully that makes sense. Your next assignment will basically be using bagging and boosting, and you could theoretically do the assignment without really understanding what's going on behind the scenes, but it's good to know what this stuff actually is, right? Instead of just kind of clicking some buttons in some software, you kind of want to know a little bit of what's going behind the scenes. I didn't write it in all kinds of math terms, and you can get very mathy with this and do this in proper notation. But I just wanted you to kind of get the concept, get the intuition of what exactly is going on when we talk about Bootstrap aggregation.